I never know whether it's day, morning, evening or what for you guys watching, but welcome back to our videos. This video is just introducing our electrics, starting off with the construction of the batteries and testing everything. It's a fairly technical one, so you need to excuse it from that point of view. Even in editing it, Hanneke wasn't quite sure what I was talking about and just did what I said. So hope you enjoy it. As I said, very technical as opposed to the nice traveling ones which she's doing. So hope you enjoy it, and please like and subscribe to everything that we do. Thank you. There's
you know what, Dad?
the lounge ones end here. Okay.
You need one on this side.
You took it out where you put the vent in.
1, 2, 3, 4, 5. Nothing done.
Yeah, we moved that one to the back there because of the vent.
But you might have not done it then because we've got the side lamps.
Yeah? What? Is the Baba asleep? Where's the baby shark?
So what's the purpose of this exercise?
To test the inverter.
To see if it works.
A lot of Chinese equipment that you get doesn't go near the specs which they say. And so we're going to put this a bit of stress to see if we can get near the specification.
What, the inverter?
Yeah.
Is it Chinese?
Yeah. But it is a more reputable brand.
Yeah. Okay, so it's 2 on each, huh?
Yeah, it's because one cable's not thick enough to carry the current.
Is that the battery? That's the long battery.
Yeah, it's a big battery. This car. Even the battery's not big enough to drive this on its own.
And what is now going to run this? The batteries?
The battery and the alternator. What I'll do is, before I connect the positive to the battery terminal, because the capacitors in here need to get charged up, and they charge up very quickly, so they will draw a lot of current very quickly through, and it'll spark like anything if I just touch it to the terminal. So I'll first use this between the two, so it stops the current flowing that fast. Let the capacitors charge up, and then I can connect it, because the capacitors will hold their charge while I do that. While I connect it. Good. Okay. So. So the capacitors should be charged up. So I shouldn't get a spark now. I'll put these on. These are the leads supplied by the battery manufacturer. I mean the inverter manufacturer. Oh, not. This is 12 volts. Okay, so we've connected the inverter, we've switched the engine on. Now we come to switch on the inverter. I'm not going to use the remote yet. See, it's charging up, stabilizing. So it says we've got 14.1 volts on the alternator and 230 volts output. So let's go from here to connect the rest of the equipment. Okay, so we've now connected the inverter with the power meter on it, and you can see in standby the inverter is using 2.8 and we're on watts at the moment. The induction cooker, sorry, not we've connected the induction cooker. The induction cooker is on, it's showing it. Now if we switch this one on, so it goes on, we're still at 2.8, we've gone up to 2.9, 2.8 watts. Okay, select a function. Okay, so we should be drawing 1200 watts according to the inverter, and my power meter is saying 1040 odd watts. So that seems to be going okay. We've got the remote of the inverter there, and it's not showing. The lights are on, the battery is full, and the power is on. So let's increase that a bit. That's 1300, that's going up to 15 there. If we go this, if we switch the second plate on the inverter on, and we take a low function, let's go to 1000 watts there, so we should be at 2300 watts. We're showing 2200 watts there. Okay. We're at 11.4 volts. inverter is a little bit warm. The cables are quite warm. So if we use more than this, I would actually look at putting heavier duty cables in. And these are warmer than I would like them to be. And that's at 11.4. How much are we still using there? How many watts?
We are still using 2,150. And water's starting to boil
Okay, good.
slowly.
2,150 watts. So we're going about 180 amps.
180 amps, okay.
Okay, what's that beating?
Don't know. Still at half battery.
Yeah, well, we're down at 11.4 volts.
Okay.
So I would suggest switch off one of the plates.
Okay, we're down to slowly going down to 1,000
Sorry.
watts. Slowly going down to 1,000 watts.
Okay.
Battery's gone up a quarter,
Yeah.
nearly full. And water's boiling. Or bubbling slowly.
Inverter actually is quite warm.
Okay.
But I wouldn't be able to hold it for too long. So I have my doubts whether we would be getting 3,000 watts continuous out of this.
Yeah. Before it becomes a fire hazard.
But I'm sure it can surge well beyond that. But it is working, and we've got pretty close.
Yeah.
We've got a reasonable current out
Should
of
be
it.
at 12 volts again now.
Yes, we're at 13 volts now, so the battery is starting to climb up again. I also don't want to overstress the alternator, so I haven't. That's why I didn't run it for too long. Okay, interesting enough, the fan on the inverter has just kicked in, so it obviously would run at a higher. The thermostat is put quite high. As usual, the supply of equipment and that we need for the van is rather difficult in UAE. So I had to import. And in importing it, I got a charger from the States, which they said would work on 220 volts, but was actually 110. So I had to convert it. I got hold of the manufacturers, and they said, yes, it will work on 220. I just had to make a small adjustment to it, and that was cut one jumper cable in the charger itself. So that you'll see, Hanneke will put in an arrow to it just now. But this is the charger which will give me 40 amps into my lithium batteries. So here you can see there's a jumper cable down the bottom, and if you look very carefully you can see it's been cut. And that cutting allows it to work on 220 volts. So, where are you? There we go. In order to do the testing of these electrics, I'm going to run some cable from the current car battery through to here and put it onto a bus bar. This is just a temporary measure until I actually get the leisure batteries, which should arrive in the next week or two, but they're coming from China on some slow boat, very slow boat. Good morning, guys. We had a nice package arrive last night. My batteries, or should I say the cells for the batteries. Just some background, I ordered them off AliExpress. I initially ordered them on the 25th of February. Today is the I think it's the 13th or 14th of July. Yeah, this is going to stop the camera if I do that. I waited until middle of May after ordering in end of February to the middle of May. Eventually got hold of the supplier and he said, oh no, Chinese customs had held up the order. So he cancelled that order and I ordered another lot. That was in the third week of May, and they've arrived today, last night. After much chasing, I wasn't going to go through the same problem again, and so I chased like anything. And well, let's see what we've got. These are lithium iron phosphate. It's a 280 amp hour battery. Now, one of the disappointments with this is when I ordered them on the site, it did show them having the Q code on them, which is generally a good indication that these are new batteries and not reconditioned. So if you look here, for instance, there's a lot of scuff marks on the top here. A number of these have got scuff marks there, black, which should or could only mean that they've been used for something else before. But looking at these, looking at the side of the battery, it does look fairly straight. There's no bowing in it. It does look in a reasonably new condition. The nice thing with the lithium iron phosphate batteries is it doesn't matter what orientation you hold them in. Just looking at this in the light, there is a lot of scratch marks on the side, so it does look as though has a potential of being reconditioned. It does not look, those scratch marks would not come from this phone. So there is a little bit of a concern there. We obviously need to go through them. My intention is to take them out, connect them all up in series, and then top balance them, and then do a capacity test as well. So they are a reasonable weight. Each cell is 5 kilo, just over 5 kilograms. So let's unpack these and see where we stand. As there are no Q codes on them, they obviously have no serial numbers. So what I will be doing is marking them, numbering them, so that I can work with them and identify each one on a regular basis. So, counterintuitively, the white is the negative and the black is the positive. Okay, so next thing is to connect them in parallel, in series. Check that the depth of the screw if it goes in fully, will not hit the bottom of the battery there. Because I really don't want to be careful about not damaging that. So that's 7mm. Okay? No, this bus bar has a slight lip on it. The actual depth of the bus bar is 1.5. And I need another 6, 7, 8 here. So looks like us doing one at a time, or I can make additional bus bars. You can see bulging here between these two cells. If I push them together, I can see light, quite a bit of light in between there. So there is a fair amount of bulging, which is not very good. Between cells 3 and 4. Right, so I've made a whole lot of bus bars here. Yeah, you can see there. So let's put them on the batteries. As I said, we'll connect this all in series. Check my voltage across them. As we said, I understand that this is the positive, that's the negative. Three point 303 in the middle, near the middle of the batteries. Also very new and slippery. Okay, if we bring the amps right down. Okay, so my voltage is now stable, and I can let the amps go. They don't supply a detailed spec sheet, so I've downloaded a spec sheet from another battery maker, and just looking at the graph of the discharge, we're very close to the zero there, pushing the voltage up to 3.6. The voltage across the terminals has gone to 3.05, so yes, we are 3 amps through this cable, should be okay. You can see it's already dropping there. Unfortunately, being a cheap supplier, they do not supply a detailed spec sheet. That's just the fan on the power supply kicking in. They don't supply a detailed spec sheet, so I've downloaded a spec sheet from another battery maker. I've connected that all together. Here's the BMS, and what I thought of doing initially was mounting it on the side here, and so I've turned these are when it arrived, these were facing out that way. But all of this is closed. The fan draws air in there and blows it out here, and the connectors go in there. So I thought of connecting that there. I might cut a hole through, but the problem putting it on here is it makes this longer, which takes up my real estate in my shelf where I'm going to put the batteries. So for now, I'm just going to connect it here, just to get the battery charged. I may land up actually mounting this on top, in which case that could go there as well. But for the meantime, we'll leave it there. Now let's connect this. Okay, this BMS does have a temperature sensor, which I assume, well, there are parameters in this, so I can put the minimum temperature that it will charge at. We'll leave it there for now. And then this is the Bluetooth dongle. So all of the parameters in the BMS are accessible via Bluetooth. So the next thing is to connect up the BMS. Now to actually activate it, we need to apply a charge to it. So I need to get the charger out. That's as hot as my hot air gun goes. The inverter is a little bit starting to warm up. I'll just have to be careful of these cables. I will continue to monitor it, temperature. Now all the cables are starting to warm up. But these thicker cables from the inverter that came with the inverter, so the cables which came with the inverter are obviously cheap Chinese things, because they are starting to get warm. And so I have a single pure copper cable there coming from the battery. I will continue to monitor it, temperature. Now all the cables are starting to warm up. But these thicker cables from the inverter that came with the inverter are quite a bit warmer than this one, which is one I made up. So 155 amps at the moment. So I set this at 300 to start with, so that I can do a full capacity test. I don't want anything shutting off too soon. We're drawing 155 amps. Now this cable, the single cable from the battery, I will ultimately have two batteries running. So the chances of me ever drawing a full 160 amps from one battery is not very high. Uh, 3,000. What's if I'm drawing? Need a calculator. So I'm drawing just under 2,000 watts. And since my inverter is rated at 3,000, it should cope quite well. Well, we'll leave that going for a while and we'll come back later. Are warm. The primary positive and negative terminal are quite warm, but the ones in the middle are only mildly warm, with the batteries now warming up. So we'll keep it going. That's 90 amp hours left, so we should have about 70. If the batteries go to full capacity, we should have about 70 amp hours left to drain. (233 amp hours when it's supposed to be 280.